Okay, guys. Quite a few people have asked me what the bisection method is. Why would you use a bisection method? Um, and they said they can't get onto the link, so I thought I'd make a quick YouTube video on how to do it and why we would use it. So, basically, we use a bisection method to find an x-intercept or a root without having a CAS calculator. The ironic thing is we use a CAS calculator to work it out. But you could use a scientific calculator. It's just really painful. So for this example, I'm going to use the function, it's a good function, y equals x squared minus 3. Okay, so we know if we sketch that, it's going to go through root 3, negative 3, root 3, and it looks like that. Okay, so we know the exact value is root 3, but if we had a nasty function, like e to the sine x plus tan x minus 4 pi on 3, and we wanted to find the x-intercept, this is when we would use the bisection method to find an approximate intercept, because you wouldn't be able to solve that equation. However, the bisection method will allow you to get the intercept without actually, it won't give the exact value, but it'll give a really good approximation. Okay, so the way that the bisection method works is we know where the intersection point is approximately. So here, assume we don't know it's root 3. Actually, let's zoom in on that spot. Okay, so just say we had that curve. So it looks like that. It's not going to look like that, actually. It's going to look like that. Okay, we know that that's the point 1 and that's the point 2. So we know that the intersection occurs somewhere between 1 and 2. In here it looks like it's perfectly in the middle. However, it's not a great graph, so it's not exactly in the middle. But what we do is we call this A and we call this B. Now, if this is the point A, then f of A is this point here. And we know that f of A is negative because it's below the x-axis. There's the x-axis. And f of B, there's B. F of B we know is positive because it's above the x-axis. Now, if I've got a point that's below the x-axis, and I've got a point that's above the x-axis, and it's a continuous function, well, somewhere in between there, I must go through the x-axis if it's a continuous function. So there's got to be some sort of intercept in between them. So what we do is we'll create a table, and in that table we have A and B, which is A is to start off with, it's 1. B to start off with is 2. Now bisection, as the name suggests, by cut into 2. So we basically want to find the halfway point of these two values, so A and B. So if I say A plus B on 2, what we're doing is we're getting the value A, we're getting the value B, and then we're halving it to find some value in the middle. So if I add 1 plus 2, I get 3. If I divide it by 2, I get 3 on 2. So I've got the point A, I've got the point B, and then I've got the bisection point, the point in the middle. From there, we also want, we know f of A. So when we put 1 into this function, if I put 1 into this function, I get 1 squared, which is 1, minus 2, so that's negative 2. And we know f of B is when we put 2 into this function, we get 2 squared, which is 4, minus 3, which is 1. So that's positive. And then I'm going to find f of a plus b on 2. So when I put 3 on 2, if I square that, I get 9 on 4. If I take away 3, that's the same as 12 on 4. That's going to be negative, right? So from now on, instead of saying like negative 2 and negative 1, I'm going to get rid of this and just say that this is negative and this is positive. And then f of a plus b on 2 is negative. Now, because it's negative, what we want to do is the value that was negative, I want to replace it with a plus b on 2 because it's a better approximation. Now I'm going to show you, I'm going to draw a little graph again. This time I'll try and make it clear. So here's my original graph. There's the point going up. There's A. There's B. A plus B on 2 is somewhere here. Now we just said f of A is a negative value. F of B is a positive value. When I found f of A plus B, it was a negative value. And it's a negative value that's closer to the point of intersection. So what we're going to do is scrap this value, the A value, and we want to replace it with A plus B on 2. So because it was negative, we replace A with A plus B on 2. So A becomes 3 on 2. B stays as 2. Then everything else we've got to recalculate. So A plus B, 1.5 plus 2 is 3.5. When I divide that by 2, I'm going to say 1.75. And then we say f of A, well, we know f of A is negative because A is now A plus B on 2. We know f of B is positive because it was positive before and it hasn't changed. F of A plus B on 2, well, we have to calculate whether that's negative or positive. So we've got to put 1.75 into x squared minus 3 and then see what it is. Now what I'm going to do is show you how the easiest way to do it, which is on the calculator. Okay, so if we go out, our function is x squared minus 3. I define that to be f of x. I then want to store my left-hand value, which in this case is A, and it starts off being 1. So 1, this little thing here, the little arrow, that means store. So I want to store 1 into A. And I want to store 2, my original value, into B. Oops. Okay, and then we want to calculate A plus B on 2. Because basically we want to fill out this table without having to do anything. So we can get the calculator to do all the work for us. A plus B on 2. Okay, so it's 3 on 2. And then I want to find f of A. F of A. For some reason this stupid thing puts a Z in every time. F of B. And then f of A plus B. Where are we? A plus B on 2. Okay, so you could see it was negative the first time. Because it was negative, we replace A, because that was negative, with 3 on 2. So we go up to the top. We replace A with 3 on 2, so change that to a 3 divided by 2. Hit enter, and then it recalculates everything. So I've got A, B, 1.75. F of A is negative, F of B is positive. F of A plus B on 2 is positive. So if we go back here, that's positive. So this time we've got to replace B with 1.75. So say 1.75. And we'll make that 1.5. And then, yeah, so because it was positive, we replace our B with our a plus b on 2. Okay, now when we go up to the top, so we go up to the top, we replace b with 1.75. I'm going to change it to decimal because we're going to start using decimal soon anyway. So I change it to 1.75, go up to the top, hit enter again. Okay, we've got a is 1.5, b is 1.75, a plus b on 2 is 1.625. So 1.625. F of a we know is negative, f of b we know is positive, and f of a plus b on 2, if we go down, we get negative. So because it's negative, we then go across. Now what was giving us a negative? A was. So now we replace a with a plus b on 2. So let's say here 1.625 and 1.75, and we've got to replace a. So up here, replace a with 1.625. Hit enter. Okay, so our midpoint's 1.6875. 1.6875. That's negative, that's positive. 1.6875, let's see what that is. That's negative. Now because it's negative, we replace a with 1.6875. So 1.6875, 1.75. Let me replace, go up here, 1.6875. Hit enter. Okay, our midpoint's 1.71875. 1.71875. F of A we know is negative, F of B we know is positive, and F of 1.75 is negative. So it's negative. So this time we replace A again because it's negative. So 1.71875, 1.75. Okay, 1.71. Hit enter, XE. Okay, 1.734375. 1.734375. We know that's negative. That's positive. Now this number here, is that negative or positive? That's a really small positive number. So because that's negative, that's positive, that's positive. This time I replace 1.75 with, so say 1.71875, 1.734375. Okay, let's go up, copy, and I was replacing B because B is positive. So go up here, edit, paste. Okay, go back up, hit enter, and our midpoint is 1.7265625. 1.7265625. We know that's negative, that's positive. We've got to see whether that gave us a negative value. So because it's negative, we replace A. So A becomes 1.71, 1.7265625. B is 1.734375. Okay, we've got to find the midpoint. So because it was negative, we're replacing A. So we grab that, edit, copy, paste it here, edit, paste, edit, paste. So right way, 625. Enter. Okay. 1.73046. 1.73046. 875. Okay, we know that's negative, that's positive. And this one I had a look before, it is negative. but it's getting really small. So here, because it's negative, we replace A with 1.73046875, and here I've got 1.734375. If we find the midpoint over here, okay, so we want to replace, because it was negative, we want to replace the left-hand side, so edit paste. Go through it all again. 1.73242. 1.73242. Negative, positive. When we put it in, we get really small positive. So this time we replace B. 1.730468. 1.73242. Okay, copy that. Now it was positive, so replace B. Now I don't know if you can see, but look at these three numbers now, 1.73, 1.732, 1.731. Slowly, it's moving to what the exact value is. So 1.73145. 45, that's negative, that's positive. In this case here, where did it go? In this case here, we know that that is negative. So we would replace A. Okay, so basically what we've done, here's our graph, there's 1, there's 2, there's our graph going through. Now we call them iterations. Each step is an iteration. So in the first iteration 1, we chop it in half. We get to here. We get rid of that. Then iteration 2, we chop it in half, and then we get rid of this. And that's our A and that's our B. And then iteration 3, we chop it in half, and then that might be a negative, so we replace that, and then we go again and we chop it in half, and eventually, because you keep chopping it in half, eventually you're going to get to the point, which at the moment I'm thinking is 1.73145 as an approximate. Of course, you could keep going. So let's have a look. What is the square root of 3? 1.732, and our approximation at the moment is 1.73144. So we nearly got there. You can keep going and, get really close to this value. And in actual fact, when the calculator is approximating root 3, it probably uses bisection method or Newton's method or something you probably don't know. But what it's trying to do is find an approximate value. So it keeps going until it gets to a certain error. So maybe to like 8 decimal places, and then it says, okay, A and B are exactly the same value to 8 decimal places, so I'm going to assume that this is the root, and that's our answer. Now I've got a program on my CAS. If you define the function, which I have, actually I probably don't have it on here, I just realized. Program, no I don't. Okay, so you're just going to have to be happy with going through this manually. So you define your function, work out which one is positive and which one's negative, because sometimes you'll have a function that's like this. So A could be giving you a positive and B could be giving you a negative. So you can't always assume that A gives you the negative value and B gives you the positive value. It could be the other way around if the function's a decreasing function. But you can see the method that you go through. So we go step by step, A, B, find the midpoint, evaluate f of A, f of B, and then evaluate the midpoint. Because the midpoint's negative, we replace the value that gave us a negative previously, which in this case is A. So replace that over here. And then we do it again, add the two together, find the midpoint, F of A we know is negative, F of B we know is positive. Then if I put 1.75 into the function, because it's positive, this time we replace the value that gave us a positive before, which was B. We replace it, so there, and then we do the same thing again. Grab those two values, halfway point, negative, positive. When we sub the halfway point in, we get a negative. So here we replace A with, so we replace A, and we leave B to be the same. If you want, you could call this C, and you could say F of C, and then you know you've got to replace A or B with C. The way you would do it in this case is you would say store that into C. Where's C? C. And then here you'll just do F of C, and it works it out for you. Yeah, so it's basically the same thing, but you're storing it into C, and then you're going, okay, F of A, my left hand point, my right hand point, my midpoint. C is my midpoint. Because it's negative, I would replace A. If it was positive, I would replace B with my value of C. Hopefully that made sense. So that is how you do the bisection method to work out a root. So if it doesn't give you values, you would really need to test. So if you're unsure, so just say we had x squared minus 10. So if I had x squared minus 10, and I want to know, okay, I want to find the root, and I'm not sure what it is. So you would have to go, okay, x squared minus 10, we need to find a negative and a positive value. So if I said, given x equals 4, that's positive, 3 is negative. So we know the root's got to occur somewhere between 3 and 4. Because it's got to occur somewhere between 3 and 4, we could let A equal 3 and B equal 4, and then go from there. And then from then on, we could work out. So if we define this, and then I said 3 into A, 3 into A. Stupid thing is putting a Z there. Okay, and then 4 into B, and then A plus B, A plus B on 2, store that in C, and then we can do F of A, and then F of B, and then F of C. And because it's positive, we replace B. So I replace B with 3.5. Okay, because it's positive, we replace B again. So 3.25. Because it's negative, we now replace A. So 3.125. Positive again. So we replace A with 3.1875. Positive again. So we replace A, 3.21875. Okay, positive. We replace. Oh, have I stuffed it up? Let's go back again. So 3 and 4. Okay, because it's positive, we replace B. So B becomes 3.5. Because it's positive, we replace B. It becomes 3.25. Because it's negative, we replace A with 3.125. Because it's positive, we replace B with 3.1875. Because it's negative, we replace A with 3.15625. Okay, because it's positive, we replace B, 3.171875. Because it's positive, we replace B, so 3.164, 0625. Because it's negative, we replace A, so edit, copy, paste. Because it's negative, we replace A, so edit, copy, XE. Positive, so replace B, copy, replace B. Okay, so we've got 3.1625, 3.163, 3.1621. So we can say it's accurate to 2 decimal places. We could go again, so because it's positive, we replace B. Here it is positive, so we replace B again. This time it's negative, so I replace A. It's a really small number, but it's a really small positive number. Because it's positive, we replace B. So here, edit, copy. Okay, really small negative number. So 3.1622, 3.1622, 3.1622. Now let's work out what the square root of 10 is. 3.1622. So there you go, we've used the bisection method to find out what the square root of 10 is. So hopefully this gave you a good idea of what the bisection method is and what you use it for. Like I said, generally it's not used on these basic functions, and your calculator does use it sometimes to find what a root is. So when it's trying to find like an x-intercept that's not exact, it's a method that it might use. But generally it uses stuff like completing the square for quadratic functions. So it is just a method. You can learn it in university, and you can move on to much higher, quicker methods, things that might get a solution very quickly. But at the moment, we're just learning bisection method. Like I said, it's called an iterative method. Iteration means that it's repeating over and over again. And of course, if you did it as a computer program, it'd work a hell of a lot faster because it would evaluate it quickly and it'd just do the repetitive steps by itself. Okay, let me know how you go with this, and if you need any help. Hopefully you get an idea of what you should be doing and how you can find out what the root is of an equation without actually having a CAS calculator or using other methods. You can find out what an x-intercept is or a root to a few decimal places pretty accurately. All right, good luck. Bye.